Unit 3, Lesson 8, Optimization Problems. Number 1, the height in meters of a football, t seconds after being kicked, is modeled by h at t is equal to negative 4.9 t squared plus 10t. When does the ball reach maximum height? So whenever you hear the word maximum, you want to think of a vertex. The vertex is the maximum point on that parabola. So to answer this question, we need to be able to identify the vertex of h at t. Now h at t is written in standard form, so let's convert it into vertex form by completing the square. So let's factor out the a value from both these terms. Now let's figure out what value we need to add and subtract inside the brackets to complete the square. So we take our b value divided by 2 and square it. Now we need to remove that added negative term through the process of distributive property. So we're going to multiply it by negative 4.9. And now inside the brackets is a perfect square trinomial, so we'll factor it accordingly. So as a result, our vertex is at 1.02 and 5.10. Okay, so we just have to interpret this. So that means that after 1.02 seconds, the football reaches a height of 5.1 meters. So the question asked us, when does the ball reach the maximum height? So we want to use the x value of our vertex. So we say, therefore, the football reaches its maximum height after 1.2 seconds. Number 2, a farmer has 50 meters of fence to make 2 rectangular pens as shown. Determine the maximum area. So I'm going to label this first. Okay, so we have length and we have width. So the first thing you want to do in a question like this is find 2 equations, because there's 2 variables, that encompass the variables in the diagram. So those 2 equations that encompass length and width. Okay, and it's kind of obvious that those 2 equations are the area formula and the perimeter formula. So the first equation is the perimeter. So the perimeter of this rectangle is going to be 4 lengths plus 3 widths. Okay, and our second equation is about the area. So the area of this pen is going to be 2 times L, right? The length is made up of 2 of those variable L's. So 2L is the length times the width. Okay, now let's plug in the value from the question. So we know we have 15 meters of fence. So that's the total amount of fencing. So that's our perimeter value. Okay, now we're going to combine these 2 equations. So in these types of questions, you always have a given equation, which was our perimeter, right? We were given the value of 50, which was the perimeter, and you have an equation that needs to be optimized. So we need to optimize our area formula using our perimeter equation. So let's go ahead and isolate for W in our perimeter equation so that we can then plug it in for the W and only have 1 variable in our area formula. So I'm going to take this equation and isolate for W. And then I'm going to take this and plug it in over here. So now that we have 1 formula, let's go ahead and find our zeros, right? Because if we're finding the maximum of that graph, requires you to find the zeros, then the axis of symmetry, and then plugging that into your equation to get the optimal value. So let's do the same here. Let's find our zeros. So our first 0 is at 0. And let's find our second 0. So let's find our axis of symmetry using these two zeros. Okay, and remember this is all on the way to finding the vertex, which was our goal from the very beginning. As soon as you see maximum, you want to think find the vertex. Okay, so we know that our maximum area is going to be generated by this x value. So let's go ahead then and take that x value and plug it back into our area formula. This will give us our maximum area, which is what the question was asking for. So our area formula was 2L 50 minus 4L divided by 3. Now we'll plug in a length of 25 over 4. And now we'll go ahead and solve. So therefore, the maximum area that can be generated with 50 meters of fence is 104.17 meters squared. Number 3, a bus company has found that a ticket price of $20 will sell out a 36-seat bus with no extra demand. They have also found that each $2 price increase will deter one person from buying a ticket. Part A, determine the ticket price that will maximize revenue. Okay, so just as before, we need to find an equation first. So that's going to be the revenue equation. So X is going to represent the number of $2 increases, because if you look, every single part of the question depends on the number of $2 increases. So let's come up with our equation. So revenue is equal to the price of the ticket times the number of people. Now let's put our information from the question into this equation. Let's plug in what we know for the price of the ticket. Well, we know the price of the ticket is $20 plus $2 per increase, so 20 plus X. Okay, in terms of number of people, we know that there are 36 people on that bus, and it decreases by 1 for every $2 increase. You can see how everything always comes back to depending on that $2 increase. So 36 people in total minus 1 for every $2 increase. So there's our equation. Now let's find our zeros, because that's the first step to finding the vertex. Okay, why are we finding the vertex? Well, look, it asked for a maximum. Okay, so we have both of our zeros. Let's find our axis of symmetry. Okay, so just so you remember, this means that 13 $2 increases will create your maximum revenue. So remember, part A is actually asking you to determine that ticket price, right? We only know how many increases we need to add, but let's actually calculate that ticket price. So ticket price was represented by this equation, 20 plus 2x, where x is the number of increases. Okay, so let's plug in 13 for x, and then we'll solve to get the final ticket price. Okay, so therefore, the ticket price that maximizes revenue is a ticket price of $46. All right, part B, suppose that the cost of running a bus is $200 plus $4 per person. Determine the ticket price that maximizes profit. So we're going to do the exact same thing again, except now we need to incorporate this piece of information into the cost. And we're dealing with profit, not revenue. So let's do the same steps. First, let's find an equation that encompasses the information in part B. So let's use our profit equation. So profit is equal to revenue minus cost. Okay, now let's plug in our values. So what is the value for revenue? Well, we used revenue equation in part A. Here's our revenue equation. So we're just going to plug that in to our profit equation. And then our cost is what's new. Our cost is $200 plus 4 times the number of people. Okay, and I got that information from part B of question 3. Okay, now we need to plug something in for number of people, right? We can't just make that another variable, like put in y, for example, because then we have 2 variables in our question. So lucky for you guys, we have a formula for number of people above in part A. All right, look at this. Number of people is equal to 36 minus x. Okay, now we have to do the same thing as we did in part A. Let's simplify this, and then we are on our way to finding the vertex. So we're going to use FOIL on these first 2 sets of brackets, and now we're going to simplify the second set of brackets using distributive property. Okay, now let's combine like terms. And now let's distribute that negative sign so that we can get rid of those brackets. Now let's combine like terms. Okay, now we have an equation to work with when finding the vertex, because remember that's our end goal. So let's take this and now find our vertex, right? It's always make an equation based on what the question is asking for. Plug in your values from the question, so what's given to you in the question. Then use that equation to find the vertex. Okay, so we have to factor this. And I'm going to write it in the correct order so that we don't mess up our A, B, and C values. Let's use the quadratic formula to factor this. Okay, now let's find out our 2 x values. So the first x value is negative 5.6, and the second x value is 33.60. So we have to look at these 2 values and ask ourselves which one makes sense. Remember, x represents the number of $2 increases, and because you can't have a negative value to represent the number of increases, right? You can't increase it by negative 5.6 times. We can actually rule that out. So therefore, we can conclude that 33.6 $2 increases will maximize your profit. But the question asked us what the ticket price was that would maximize profit. So let's go ahead and figure out what the ticket price is. So this is our equation for the ticket price, simplified. So we'll use that to calculate our ticket price that maximizes profit. Okay, so let's find out our ticket price. So our equation for ticket price is from above. Here's our equation for ticket price. So we'll use that and plug in 33.6 for the number of increases to find out our ticket price that maximizes profit. So therefore, a ticket price of $87.20 will maximize profit in Part B.